All right, study group.
Yes.
There we go, even better. All right. Okay, so I know everyone's paying attention right now, not
Sure.
whatever you're doing over there.
Okay.
All right, Tater Tot, where's that pile? There we go. All right. It's all greasy on the bottom.
That is.
That's a sign of a good pile of tater tots.
It was frozen.
What?
All of the food we served in the cafeteria was originally frozen.
I know, that's disgusting. One thing, no, come on, make real food.
No, that's too much work. It's already too much work trying to lay out 300.
But it, it's kind of their job, right? You say too much work, but that's what they got hired.
Time if you give us like prep it.
Okay. Anyway, alrighty. So now that my video is messed up, let's go ahead and take a look at our notas for this one. So differentials, linear approximations, and Newton's method. Okay. So when we're doing this differentiable function, the derivative can be defined as we're taking the limit as x, delta x approaches 0, because we have both left side and right side. As they get smaller and smaller and smaller, they get closer and closer and closer. So think of a secant line, think of the left side and the right side, and a secant line is just a 2 points on a line, and they get closer and closer and closer, and that gives me what my delta x is approaching to 0, so I could have the slope of a line at a point. Using a limit process, so f prime, so it's about the derivative of f of x is about what for your delta x, when delta x is about 0. So as we're approaching 0, but it cannot equal 0 because otherwise that would be
Undefined.
undefined. Okay, good. Let y equals f of x be differentiable to function, and let delta x denote change in x. So again, where it cannot be equal to 0. So for this one right here, find the differential dy. So we're going to go through and we're going to do derivatives. So we're going to work backwards a little bit. So going with what we had and thinking about the slope formula, find the differential dy. So isn't dy the same as f prime? Say yes.
No.
Yeah, so f prime, so we're taking the derivative of x. Of f in terms of x. And it's the same as saying dy dx, right? Say yes.
Yeah.
Okay, dy dx. So, there we go. Where'd that come from? Okay, so dy, so I have x e to the x. So y equals x e to the x. And then if I take the derivative, it's dy dx equals, isn't that a product rule?
Yeah.
That is a product rule. So let's go ahead and product rule this one. So it's f prime g. F prime is going to be 1. G is
E to the x.
e to the x plus sign g prime f, right?
Yeah.
G prime, what's the derivative of g?
E to the x.
E to the x times,
X.
so it's x e to the x. Again. And so from here, dy dx, so what I'm going to do is I am going to multiply both sides by dx. So it's going to turn into dy equals the quantity e to the x plus x e to the x dx. This is going to come into play a lot coming up here soon when we do antiderivatives. So I got my dy, compare dy to delta y when x equals 0 and delta x equals 0.5. So what we're doing is we're evaluating for those now. So I'm plugging in 0 for the x, and delta x is going to be 0.5. So dy equals, I said x is equal to what? 0. So it's e to the 0 plus 0 times e to the 0 times, what am I replacing dx with, delta x with? What is e to the 0? Anything to 0 power is 1, right? And this one right here, it's going to be 0, right? So it's going to be 1 times 0.5. So my delta, I'm sorry, this left side over here is supposed to be a y. I'm not very good at penmanship. Wow, why do you change to purple? Come on now. dy, so dy is equal to 0.5. So that means my slope is 0.5 there. So what I'm doing is I'm getting closer and closer to my 0, because that's what a limit is doing. As x approaches 0, we're getting super close to this. So right now, as it's 0.5, my slope is 1/2, right? So now I'm going to get my delta x even closer. So I'm going to get it even closer by plugging in 0.1. So let's do that again. So 0.1, so dy equals, that's e to the 0 plus 0 times e to the 0, 0.1. And this one right here, dy equals 0.1. Yes? Okay, keep going. So the next one, I'm plugging in for 0.001. So dy equals e to the 0 plus 0 times e to the 0 times 0.01. Again, that's going to give me 1 times that. So dy is 0.01. So what does that say about my slope? As it's approaching 0, what is my slope doing? Is it keep getting smaller? My delta y keeps getting smaller and smaller and smaller. So as that works out, okay, as this approaches 0, what's happening? This keeps getting 0 smaller too, doesn't it? So let's go ahead and interpret this by graphing it. So right here on this last one, right here, says interpret the results. So we're approximating this and getting closer and closer to delta x being 0. My close right there. So let's go ahead and look at our calculator for this. And I love these calculators for this because it does amazing things. Okay, so I'm just going to hit that scratch pad there. And I want to know e to the x. I'm sorry, x e, oh, wrong e, e to the x. All right. So now, again, these calculators are super awesome. So what I'm going to do is I'm going to go Menu, Analyze Graph. Oh, hey, look. dy dx. So what it's doing is at 0.5, 0.5, 0.5. Okay, it's way up here. Okay, so let's do it again. Let's go 0. Dang it. I gotta do it again. Menu. And so, let's see. We could actually trace right here. It gets closer and closer the more that we get to there. So if you notice, it's starting to flatten out. As we get to the left, what happens over here on the left? Didn't that just flatten out?
Yeah.
So now we got the results. So we're approximating this using plugging in numbers as we get closer and closer to this. So what we're doing here is going through, it's the exact same thing that we just did. So we're finding the slope formula. So if we have this, delta x is close to 0, then delta y is about dy, and we get that doing my equation, f of x is about whatever f sub naught, that's the point that's given to me, plus the derivative of x sub naught, x minus x sub naught. So what this is actually just basically the slope formula, or like the point slope. So from point slope, this is how we get to approximate this using. So you're going to use this formula down here on the bottom to do some of these approximations. So there it is right there, linear approximation to a differentiable function at x when x equals x sub naught. So that means your initial x is given. So they give you what your x is going to be. So they refer to this term local linearity. Instead of linear approximation, local linearity. So what it is there. Find the linear approximation to this near x equals 0. Okay, so x equals 0. So let's try that. We said f of x so let's back it up to my formula. F of sub naught. Okay, so what number am I going to plug into my x? What number is given to me? 0. Okay, it's 0. So what this is we're going to plug this in. So my original function, so this is going to be 0, isn't it?
Yeah.
Okay, good. 0. So I'm going to plug in 0 to my function. So f of 0, sine at 0. Unit circle. Sine at 0. What is sine at 0?
1.
It's all the way to the right, isn't it? Sine is y. So that's going to be?
1. Or negative 1.
Think of your circle. Over here. This is 0, right? Is this up at all?
No.
It's not up.
It's 0.
So my x is to the right 1, and my y is up 0.
Okay.
So this one right here is going to be 0. Oh, okay. All right. Let's go back up to the formula again. Plus f prime at 0. So now we have to find f prime. What's the derivative of sine?
Cosine.
Cosine. Cosine x. So f prime at 0. What's it going to be? It is positive 1. Back it up again. Times x minus x sum naught. Okay. Times x minus x sum naught. So this is going to be, let me get my notation correctly, right here. So linear approximation of x, is equal to 0 plus f prime, right, at 0, which is 1 times x plus x sub naught. What was x sub naught again? What did we start off with? 0. And what's that going to give me? Yeah, it comes out to just be linear approximation is 1x out of all those zeros that just go away. All you have to do is plug into the formula of the things that we already know. Yeah? Okay. All right, went over too far. Use linear approximation for each one of those and then graph. So, we could do the same thing using the calculator. Same thing using the calculator, because I don't want to actually plug these in like this. So let's see what it looks like using this. So to clear your calculator, just hit dock, letter B, clears it, and then we could open up a new one. And then we had sine, oh wait, wrong one. Come on, stop screwing up. Sine of x, right there, enter, there's sine of x. And then we're gonna, approximation of this, of point, was the first one was 0.1, right?
0 or...
Oh wait, there it is, negative 0.3. Menu, there we go, okay. I'm gonna do a trace graph on this because I can go to a bunch of different places. So, there is a negative 0.3, which gives me about this.
Well, you asked, you rounded it.
Yeah, would round. And what was the next one?
0.1 positive.
Okay, so 0.1.
Yeah, positive. Oh, mine rounded up.
It did. So mine's probably my settings. So if you want to change that, you just go dock. Settings is 7. Document settings. And I have mine set to float 6.
Mine is 0.62.
Here, let's do fix 6. So it's always going to show me 6. Hold on. Let me see. can't remember now how I actually got it to do this all the time, to be more than this. We'll be fine.
Yeah.
All right, what was the other one? So after 0.1.
0.4.
So 0.4. There we go. Next one is what, pi over 4?
0.5.
0.5. Then pi. You can type in pi. You can just type in the letter pi, or pi is down here in the bottom left. Pi over 4. So we're approximating all those. Just had the calculator do it all for us. Now, before we get too far into this, I want you people actually having time working on this. Hopefully, you all wrote down the previous.
No.
No?
Well, you wrote down the previous.
The homework. I'm sorry.
Oh, the homework now.
Yeah. Okay. So I'm gonna give you guys time on this. Everyone finish 3.4?
I turned it in.
Did you? No? Yes? No? No? Okay. So let's have some time right now. If you are done with 3.4, you can start working on the homework for 3.5. Use your calculator to do your approximations. And other than that, like, share, and subscribe. Hit that notification button.